Hi there! In this video, I am going to demonstrate our online activity toolkit for context-driven activity theory, OAT for CDAT. This toolkit is built to facilitate the process of data collection from large number of users available online. The collected data and results can then be used to recognize complex activities performed by users. For example, activities performed by users at home, such as making a sandwich or making an omelette. Let us begin. We log in using our username and password. First-time users will need to register to begin using the toolkit. Let us now log in. After you have logged in, we give you a brief description of what you need to do to perform the activities online. For example, we currently test the toolkit with 5 complex activities. These include 32 atomic activities and 16 context attributes. You can drag and drop the activities or click and add them from the left pane to the right pane. Let us see this in detail on the next page. Click on the Start button to enter the activity page. On the activity page, we have the list of activities for which we would like to collect data from users. There are 2 panes which can be viewed next to each other. The left pane includes the atomic activities and context attributes list for the selected complex activity. The right pane will consist of the final set of atomic activities and context attributes after the user has finished performing the complex activity. Let us start by clicking the first complex activity, making sandwich. We can now see all the atomic activities and context attributes that may be performed by the user. For example, the user will most likely make a sandwich in the kitchen. She will definitely need some type of bread. Is likely to add some vegetables, use some salt and pepper, add cheese to it, and so on. Some things the user may or may not use. For example, the user may not require the light to be turned on in the morning, but this may be required at night. To perform an activity, the user clicks on the items in the left pane and they get added to the right pane. The user can use their own kitchen as a reference point and make a sandwich as they would usually make at home. We select the items as follows. If an atomic activity is missed or is added by mistake, we can move them up and down by dragging them in the right pane. We can also delete them by clicking on them in the right pane. After we have finished performing a complex activity, we click Submit and go on the next complex activity. Let us now view the results by clicking on the View Results link. On the results page, we can select any complex activity to view the corresponding results. We use probabilistic and Markov chain analysis to compute the transition probabilities, weights, and complex activity signatures. Let us now click on Making Sandwich to view its results. We can see the individual probabilities for each context attribute and atomic activities as seen in the graph on the right. These values are normalized to assign weights to the atomic activities and context attributes for a complex activity. On the left, we can view the transition probability matrix as a heat map. Transitions which have a value of 1 occur each time a user performs the complex activity. Transitions which occur once a while have values close to 0. zoom in and out to view these transition probability values or increase the size of the heat map by stretching it. Below, we can view the complex activity signatures with their path probabilities. These are computed and used to recognize complex activities performed by the user. We can view the complex activity signatures for different complex activities by clicking on the menu on the left. This gives us the most traversed path or the least traversed path in which the user performs a complex activity. These signatures are collected and used for complex activity recognition within our situation and context-aware complex activity recognition system, SACAR. Please go on the Activity Toolkit link provided below to try the system yourself. Thank you for your time.